have oxygen gas. Remember, oxygen in the air is actually O2. So this is when we breathe in oxygen, it's O2. It's a diatomic molecule, O2. Here we have methane. So here are the reactants in this reaction up here. So here we have methane, and here we have O2. Now, when we balance equations, we're following the law of conservation of matter. So there's got to be the same number of atoms and the type of atoms on each side of the reaction or equation, since we sometimes call it an equation because the number should be equal. However, when you are given an unbalanced equation, it is hypothetical because in nature it's not going to be unbalanced. Nature follows the law of conservation of matter. So it's always going to be balanced. Matter will be balanced. There'll be the same number of atoms on one side of the reaction as the other. Always. However, in the examples you are provided, you are given unbalanced equations which are hypothetical or imaginary. And you are to create the real equation, what it would really look like in the real world. It would be balanced. If we look at this now, we're starting with methane and O2. The products then from this are the carbons. Keep in mind the carbons are going to be the black balloons always for these examples. The white balloons are going to be the hydrogen and the pink are going to be the oxygen. So this is CO2. CO2 right here. So that's this over here. And we also have H2O. So this is a molecule of water. So this is the water, and this is the carbon dioxide. So these are your products, these are the reactants. We're starting with these. These are not together normally. So we're starting with these two. These are the reactants, and these are the products. So reactants, products. Now if we just look at the atoms, we want to figure out, is this balanced already? So let's look. Take one atom at a time. Let's look at the first atom. Let's look at carbon, black. We have one carbon over here. We have one carbon over here. Balanced. Carbons are balanced. Hydrogens. We have 4 hydrogens on this side. 4. We have 2 over here. Not balanced. Over here we have 2 oxygen, the pink balloons. Here we have 3 oxygen. Not balanced. So carbon's balanced, oxygen, hydrogen are not. So we have to figure out what do we need to do to make them equal. All right, well, we cannot change the subscripts. So we know we cannot change this 4 here. So we're always going to have at least 4 hydrogen atoms. Now, has to have 4. So that's where to start. So my suggestion with this is the first thing you're going to figure out is what types of atoms you have. And then count them. Find out if they're equal or not. Find out if it's balanced or not. If it's not balanced and you need to balance it, you're going to look at the side that has the highest number of atoms and pick the atom that has the highest number. So we're going to do that. Right here, we're looking at hydrogen. It's 4 over here, and we only have 2 on this side. Okay, we can see the white balloons are hydrogen. We've got 2 here, we have 4 here. This is not balanced. So what do we need to do to this side to make 4 hydrogen atoms? What if we multiply times 2? In other words, what if we have 2 molecules of water instead of 1 molecule of water? So here's your molecule of water. This is where the hydrogens are coming from over here. So what if we have 2 molecules of this? Then we would have 4 hydrogen atoms. And it would be balanced. So let's do it. Well, these do not normally have blanks in front of them. Okay, the blanks are for you to fill in. So we're going to put a 2 here. So now we're going to have 2 molecules of water. Okay, now let's see if we are balanced here. So again, we're going to just go back and make sure the first thing you do is write down what atoms you have on both sides of the reaction. So carbon we have hydrogen, and we have oxygen. Carbon, hydrogen, oxygen. Okay, this side we have one carbon, equal. Okay, this side right now we have 4 hydrogens. This side we have, well, originally we had 2 hydrogens. Okay, oxygen we have 2. Oxygen, remember we have, this is a subscript, we have 2 here plus 1 here. That's 3. So these are the numbers of atoms we have right now. Now, like I said, if we add another water molecule, make this 2, now this side has 4. So now the hydrogens are equal. But does that affect the oxygen? So now how many oxygens do we have on this side? So remember, if there's no subscript, it's a 1. You're always multiplying the subscript times the coefficient. You want to just think of it that way, because if there's no number, it's always a 1. So for example, here, there's no number, there's no coefficient. That means there's 1. Here, there's no subscript. That means it's 1. You can write 1 if it helps you. You don't have to write 1. It's just assume there's 1. So how many total oxygen atoms will we have? 2 oxygen atoms right here, and we have 2 over here. Okay, so now we have 4 oxygen atoms. So 4 oxygen atoms on this side, 2 oxygen atoms on this side. So they're not balanced. These are not balanced. They're still not balanced. So now I've got 2 oxygen atoms over here. So, and the oxygen on the reactant side is in the O2. On this side, I have CO2. I want 4 oxygen atoms. So what should I do to this? This is O2. What do I need to do to this to get 4? Basically double it, right? So multiply times 2. So if we have 2 of these, inflate. So now, if we put a 2 here, 2 times 2, we have 4 oxygens, and we're equal. So now this reaction is balanced. This is a balanced reaction. All right, so balanced reaction represented here. So you have to think about the atoms, count the atoms, figure out what type of first of all, figure out what type of atoms you have on each side. Count the atoms. See if you have the same numbers. Find out which ones are not the same. And then look at the side that has the highest number, right? And then the other side you're going to add coefficients to balance it. Now some of it's trial and error. The more you do it, the more practice, the better you get.